for your next activity again, which is under lipids, no, you could probably prepare sa laboratory katong mayonnaise, no, which you will use kanang the egg yolk, or you can prepare your soap and utilizing your oils, fatty acids, no, from your plant sources, and you will have reactions. So yeah, to prepare your corn soap, no, which you haven't prepared yet. Your organic chemistry, if you haven't covered it once, you can also cover that here, which is still part of lipids. Okay, so for today, we will wrap up our lesson. We'll wrap up, just a few minutes left na lang sa slides rather for our lipids discussion, and after that, humanata sa atong lipids, and then 4 meetings for your next chapter, which is the nucleic acids, the last biomolecule that we will discuss, and then we'll have our final exam. And so last meeting, I think I've asked you, what are the common fats that you use at home, and have you ever checked kung unsang mga oil sources and fat sources you're using at home, and what are its composition? Anyone? Anyone? Naka-check mo sa inyo ang mga samples at home? Now you can actually check. You can check kung ano yung gigamit. Butter, for instance. Butter, margarine, no? What is the composition of that? What is the percent saturated and unsaturated fatty acids? And since you expect, for example, butter to be solid, no, at low temperature, and even at room temperature, it's solid, you expect your butter, for instance, to contain a lot of saturated fatty acids, and you have the common lauric, myristic, palmitic, and stearic acid. And then you have your, what's the common one? Peanut butter. Peanut butter or your peanuts. Now you notice if you prepare your peanut butter, you have, may pagka-liquid siya, right? Unless ibutang nimo sa ref. So you expect it to have also a lot of unsaturated fatty acids. So you have this. Now you have always to classify whether your fatty acids are saturated or unsaturated. Okay, so, and I think I've also asked you sa inyong mga gamit for beauty products, because they're also using fatty acids there. Now, for example, there's a lot of fatty acids being used there. So you can also check, especially for mga massage oils and so on. Okay, so we'll wrap up with our fatty acids, which belongs to the biomolecule lipids. And we have seen in the previous discussion on the structures of and the differences between unsaturated and unsaturated acids, how we name them, and the number of carbons for each particular fatty acids, for instance. You have the lauric, myristic, palmitic, stearic. These are the common names. And you also have to know like how many carbons would each fatty acids have, and would there be any double bonds you can see in the structure. So we'll proceed with our discussion, and we'll talk about the structures and properties of glycerides. And you have seen in the previous discussion also know what is the triglyceride. It is the esters of the glycerols. No, you have your fatty acids bounded to your triglyceride. So when you have your sources of fatty acids from plant oils, for instance, you don't get them as free fatty acids like the carboxylic group, but instead you have the bonded fatty acids, which you have an esterized fatty acid bonded to your triglycerides. Okay, so now there's this what we call a substitute for our fats and fatty acids. So we have the olestra or olein. It's chemically synthesized. It's a mixture of sugars and fatty acids, and it has between 6 to 8 fatty acids attached to alcohol groups, and they're not absorbed and metabolized. Therefore, they are not caloric. So here is the structure of our fat substitute. And you can see here in the structure that it looks like a sugar, right? You have here your monosaccharide, where you have your supposedly when you have your monosaccharide, if you remember the structure, you would have your monosaccharide to be 6-membered ring or containing a 5-membered ring. You have a furanose or a pyranose, right? And here you can see the structure. You have here supposedly OH here, depending if whether it's up and down or left. So you will have a different kind of monosaccharide here. And you can see the structure, you just have to replace the H from a sugar with an R, meaning R is an R group, which represents this one. You have your CH3 and a number of CH2 repeated. And then you have your carbonyl group here. So you just have to repeat this one, this R, the common R here. So usually you can find these fatty acids sa mga food products ninyo, no? You normally don't use the fatty acids for reasons that the normal fatty acids that we have discussed in the previous sessions, because it can be easily oxidized, it can easily get rancid. If you notice, for example, magamit mo virgin coconut oil, di ba, after a few days, maglahi na siyang baho, no? Because it is oxidized and there will be an immediate chemical reaction, or it's being exposed to light and sun, and then there is this rancidity odor that you will smell. So for food products, they usually use a food substitute, and they call that one as olestra. So like, for example, you can check on your food products and even sa inyong mga cosmetic care products, personal care products, no? Sometimes they don't just use sole fatty acids, but it's always a mixture of sugars and fatty acids. Again, the reason is it's not absorbed and metabolized in the body, and they are not caloric. And another reason is they are not easily oxidized, no, as compared to the usual animal fats and plant oils, no, that we have. So there are chemical reactions of triacyl glycerols, and one of the chemical reaction is what we call as the hydrogenation reaction. So the hydrogenation reactions is simply an application of what you have learned in organic chemistry when we discussed about alkenes, no? And one of the reactions of alkene is that it can do addition reaction in the presence of hydrogen gas and in the presence of a catalyst, that the hydrogen from the hydrogen gas will be added to the double bond. You can actually see, can all actually produce a saturated, like an alkene to be converted into an alkane form. So since you have here, for example, your triglycerides here, and your alkane is your alkene is part of your, like a long chain hydrocarbon here, is part of your esterified fatty acids here. And you add hydrogen, now this one you will get from unsaturated, you'll get a saturated fatty acids here. And the difference again is once you get your saturated fatty acids, there is a good packing of the hydrophobic tail of your saturated fatty acids. And because of that, again, good packing of the hydrophobic tail, you expect there is more intermolecular force of interaction between this chain 1, chain 2, chain 3, and so on. Other molecules of this triglyceride. So there is a good packing, and you expect that there is a high melting point, that you would expect, and you expect this one saturated to be more solid at a room temperature as compared once you have this alkene, the kinking of your tail of your fatty acids, where there is 4 packing here, and you expect there is a 4 intermolecular force of interaction. So there is a weaker force of reaction because of the distance from the kinking here. and you expect that the weaker the molecular force interaction, intermolecular force interaction here, you expect the melting point of this to be lower. And that's why here, once you have a lot of this double bond, expect your samples or triglycerides to be liquid at room temperature. So if you want to convert like a liquid to a solid part, we have to do hydrogenation reaction. And another reason that food companies would like to hydrogenate their products is that hydrogenation of oils would prevent spoilage. No, it doesn't easily get rancid, the saturated fatty acids, as compared to unsaturated fatty acids. And I'm not sure if I have already shown you before on the reaction of the auto-oxidation process of your fatty acid.
Ma'am.
Yes.
Nag-share screen ka, ma'am?
Nag-share screen ko. Wala nakita.
Wala, ma'am.
Ayan ako. Anyway, so I was talking about the reactions of your fatty acids, wherein you can convert, for example, here, the reaction of our fatty acids from the unsaturated fatty acids. Like here, you have your triglycerides. Again, this is the form of your bonded fatty acids from real samples, animal and plant oils, no? Fats, animal fats and plant oils. You don't get, again, your free fatty acid, which is the bonded one. And the reactions that would be involved once you have your fatty acid is the hydrogenation reaction. So we convert this unsaturated fatty acid to saturated fatty acid by what we call as hydrogenation reaction. And if you remember in your organic chemistry, this kind of reaction is simply an application of the reaction. If you have your alkene, and this is an addition reaction of your alkene with your hydrogen gas, in the presence of a catalyst. And I was talking earlier, if you can see on the structure, there is an advantage why a lot of manufacturing companies, or even particularly food products, they want their products to be saturated. And one reason here, you can prevent the spoilage of your food products or your oils once it becomes saturated, because the unsaturated fatty acids tend to oxidize over time, and it causes the fat to become rancid. No? If you notice, for example, mga oils, there are oils where there's a lot of double bond. You can smell actually over time, the oils become rancid, and is one of the reasons. Like, for example, your margarine, it's not actually like the source of your margarine is not actually solid, and from a source of plant oils, they actually hydrogenated to be solidified. And again, for a reason, also your butter, for reasons that solidifying by the hydrogenation reactions, you will produce your triglycerides, your fats to be in solid form. And once you get your samples to be in solid form, they are actually in saturated form, saturated like this one. Now you don't see a double bond in the structure of your triglycerides. What you see is the saturated one. So it's solid, and again, this one, the saturated form, your fatty acids actually is less prone to spoilage. They are not commonly proceed with auto-oxidation process, unlike your unsaturated fatty acids here. And again, if you remember, you can see on the structure that once you have your saturated fatty acids, you can see on the structure by itself that there is a good packing. And you expect that because there is a good packing, there is a good intermolecular force of interaction between, for example, this chain and this chain and this chain. There is a good force interaction. But you don't see this any polar group. So the only force interaction that you would expect between these hydrophobic chains is the hydrophobic interactions by virtue of the van der Waals forces. Okay, and the longer the chain, the longer would be your van der Waals force of interactions. And the more forces of interaction between molecules, you expect this one to be would have a higher force of reaction, you would expect this one to have a higher melting point as compared when you have your double bond. You can see kinking, and you see here the distance between the chains is would increase, and you would expect there is a poor packing, and because of that, you expect there is a lesser force of interaction. No? The farther the distance would be from one chain to another, the poorer would the force of interaction by virtue of the van der Waals force of interaction. And because of that, again, you expect this one to have a poor or a low melting point as compared to the saturated. Again, so the unsaturated fatty acids, the unsaturated glycerides, triglycerides expect to be liquid, and the saturated one you expect to be solid at room temperature. And the difference between the properties of the unsaturated fatty acids and the saturated fatty acids is that this one is more stable. It doesn't get rancid easily, doesn't go auto-oxidation easily, doesn't get oxidized easily to be rancid as compared to your fatty acids yun na ay double bond. So I'm not sure if I have discussed it to you that the auto-oxidation process involved with having a double bond, but I think you have learned that in organic chemistry, no? Once you talk about kanyang mga alkenes, no? I think we talk about the alkenes, no? This part here can actually proceed with the auto-oxidation in the presence of oxygen and light, no? You will, this one will get oxidized, and that will be the cause of rancidity, the oxidation, auto-oxidation process. So I'm not gonna discuss that one, but that is the fact. With unsaturated fatty acids, it can get easily oxidized by the process auto-oxidation, and because it easily gets oxidized, no, it becomes rancid easily. You notice now for yourself, no, especially not to discriminate the medyo chubby people, right? Or even us, no, regardless of our body weights, body structure, no? Pag we are exposed to the sun and you can see that there is some smell from our body, and it's because of the fatty acids being oxidized. That rancid smell that you can smell from your body if you are too chubby or even normal. You have your fatty acids within you, and that fatty acid becomes oxidized, and expect some rancid odor, and it's a process of the auto-oxidation. And further reaction is actually being discussed in the organic chemistry. Okay, so again, in summary, this kind of reaction is what we call as hydrogenation reaction. It's one of the chemical reaction involved for the lipids. So here is trans fatty acids in some typical fast food and snacks. And so you have to be careful, no, what expect rather that for the food products that we are taking, expect that there are fatty acids being contained in our food products. So you have trans fatty acids. Normal fatty acids are in the cis, right? But there are some that have a trans fatty acid content. So for example, you have your French fries, now you have the total fatty acids about 28 to 36%, 28, 25, so greater than 20, bread, fish, burger, chicken, pizza, chips, donut, muffin. You can actually see there's a lot of fatty acids involved. Why? Okay, if you have been into baking, are anyone here who is into baking? May ga-bake dire? Wala nag-bake sa inyo, grabe sad. Anyone nag-bake? Wala? Mga girls, be? Arlisa, Camela, wala may bake-bake sa inyong high school? Sa inyong koan? It's one of the skills, no, ladies, learn to bake, and it's actually an application of chemistry. When you bake, no, you are actually using your carbohydrates, no, one of the ingredients when you are, for example, making bread, making cakes, muffins, donuts, and sapa, no, one of the ingredients you will use flour, which are carbohydrates, Okay, and then of course, when you bake, for example, bread cake, wala diri gibutang cake, no, or muffin, chocolate bar, you always use oil. French fries, magluto mo, there's also oil that's being involved. So you always use your fatty acids most of the food products that you take, no, even if like contains a lot of proteins, for example, chicken, no, it contains a lot of chicken, you are, what else? Muffins, here fries, burger, fish burger, so you have a lot of proteins there. But once you have your flour, it contains a lot of carbohydrates. Of course, those are some sources of your carbohydrates, your flours. Those are from also plant sources, okay? But when you have your, for example, muffins, or even if you just fries or whatever you fry, they always use your oils. And it is an important ingredients at home, your oils. And without that, I don't know, you don't have your fatty acids, just mag-unsa raman for me na magtula or mag-unon, I don't know what other recipes at home without using oil. But most of the food products actually that we are using, we always use oils, animal oils, even cakes, no? Kaano cake, there's a lot of oils there. Of course, there's a lot of fatty acids that you can obtain, no? So cakes and muffins, pareha-pareha rin siya. Okay, and here is the percent of serving, and then the total fatty acids, no, majority or a fraction of it, no, would have your fatty acids. The rest will be oils. The rest will be carbohydrates, no. You have your polysaccharides in the form of flour, kana? And then you have your sugars. Of course, butakan na siya sugar na para tamis. So you also have your carbohydrates, another form of carbohydrates, it's a monosaccharide, disaccharide. What else? Okay, now you can see that the food that you ate contains a lot of biomolecules. Now you have your proteins, you have your carbohydrates, you have your fatty acids. And the next chapter will be talking another biomolecule, which is the nucleic acid. So the last one. So I would like to encourage you, now that you have already, excuse me, now that you have already gone through with biochemistry, I would expect that you would be conscious on the food that you take, and you would go always to the ingredients part and you look at, okay, how many percent will be your carbohydrates, your proteins, and your fatty acids. Now, you always have it. Of course, that there is a conversion for calories intake. It's not part of our course. You can have that one. And I'm not sure if you can reach into metabolism, but all of those carbohydrates, proteins, and fatty acids, no, they will be converted. They will have further biochemical reactions in our body. And the main source will be to use to produce our source of energy for all the activities on the cells of our body. Okay. So again, we're talking about the reactions of our triglycerides or fatty acids. No, the first one is the hydrogenation reaction, and another kind of reaction is the saponification reaction. So this is what I was saying earlier on the first discussion. If you were able to prepare your soap in your organic chemistry, no, because this is also the carboxylic acid. So one of the reactions of triglycerides or the triacylglycerols, or in other words, your fatty acids, is the saponification reaction. So in the saponification reactions, we have our source or triglycerides. We have our oils, fats, or lard, no? And we react with sodium hydroxide, or even some would use potassium hydroxide, and there will be a reaction for that. And what we'll produce is, in the presence of hydroxide, we'll be able to liberate our acetyl bond OO are here. We will be able to get our CO double bond OR, the negative one, and then you will have your OH here and OH here in the second. Liberate this one. This will be substituted with an OH, this part here. This one will be liberated, and this one will be attacked or substituted, react with the OH. Okay, and this one will be liberated. So you have a negatively charged COO minus. The oxygen will possess a negative charge. Okay, if you remember on the level structure, finding on the formal charge of each atom, oxygen without hydrogen in the carboxylic acid form would have the negatively charged. So having a negatively charge, formal charge of negative for your oxygen, then it's bound to be attracted to a positive. And so the positive source will be your sodium. So here, the sodium and your organic part here, you actually get your salt. So our soap, this salt is actually what we have as our salt. And that salt is actually, we say, an organic salt. No, kanang soap, that's already what we are using at home, usually the solid ones, no? Because kanang mga, say, body wash, no, they're not using the triglyceride. They have actually a different reaction for that. And it's still an emulsifier, but they're not using a triglyceride. So the one that we're talking is kanang mga solid soap. No, example, kanang mga safeguard, ganinan na sa pa. Nag-mention ako safeguard. Kanang mga Kojic, no? Mga, basta solid, no? Nga mga sabon, no? Sa mga sabon karon. I don't know na mga sabon, no? So like that one, those are our sodium soap, soapness, you know. We usually use this one for personal use, no? There is a different kind of soap, no? Soap. We call actually detergent, kanang gigamit pang laba, gigamit pang hugas, no? It's not the soap that we're talking about na gikan sa triglyceride, no? Those kind of detergents, kanang pang laba, pang hunaw, pang laba, pang hunaw, what else? It's another use. It's pala yung gamit sa detergent. Pang laba, pang hunaw, pang body wash, no? Kanang mga body wash, minana, they are not the triglyceride one. So what we're talking, they're not the source yung gikan sa triglyceride, gikan sa animal fats and plant oils. They're actually from another source, no? There is another reaction for that. So again, we are referring only to the soap that we have nga katong mga solid ones, okay? So for this kind of reaction, we can actually prepare this one, and you can prepare this one in your, at home, no? You can prepare this at home, and you can add some additives, for example, for those lang under me sa laboratory, no? I don't know what you'll be doing for the other section. Because I like this one because you don't necessarily have to go to the laboratory sa school, but you can prepare this one at home. No? You can use our source of sodium hydroxide, ngita lang mo og lye, kanang sa grocery store, no, pang limpyo sa CR, no, that will be your source, and you have your triglyceride. If you are in the laboratory, you can request for the sodium hydroxide. So again, that will be an alternative. And then if, for example, you want your soap to be like pampaputi, no? Then you can add another ingredients nga pampaputi. For example, kojic acid, you can also add so may pampaputi. Another pampaputi, you can add milk, you can add alcohol, no, for a clear shell. There is a lot of option for which you can add to your soap just to have to get a unique formula, no? Or a unique, you can add some. In fact, there's different kind of soap, like tomato soap, no? I think I've heard it before, like tomato soap, any soap kanang antibacterial soap, you know, a plant, for example, na siya antibacterial properties, can also anything that would add value to your soap. But basically, the general formula of your soap is this. Now you have your sodium carboxylate here, or the sodium carboxylate. Your R would depend on the number of carbons, okay, that would come from your source plant oil. So you can use, for example, coconut oil, you can use corn oil, you can use palm oil. And the same, if you are you can look for a cheap oil, no? Anything. So you can probably do this by group. No, if you can do alone, and do this by group, and you can see what kind of soap you'll be obtaining from your initial source. Okay, so that would be an exciting reaction to obtain. So this kind of reaction, again, will involve sodium hydroxide. This is actually, if you remember, the reaction between this and to produce this one, it's actually a hydrolysis kind of reaction. It will actually eliminate water in the process. So in the saponification reaction, there's actually what we call the cleansing action of the soap. So why would the soap being able to clean surfaces? So one reason, if you look at on the structure of the soap, it's a similar structure with our carboxylic acid, except that one of the oxygen having the hydrogen, once it's being, because it reacts with sodium, you will get your sodium COO here. So remember your COO minus, it's actually C double bond oxygen and another carbon oxygen. Okay, and the charge for this oxygen only gets one bond. Let's see in the structure here. Wala. Okay, so here na lang. Okay, if you remember your organic chemistry, with all the left structure, do not forget all that. Carbon double bonded to oxygen. There are lone pairs here. You have duha ka lone pair following the octet rule. Remember, so you have your 2, 4, 6, 8. Imaginary duha ka lone pair here. Always remember that for oxygen, there is always a lone pair, because they would follow the octet rule. All the atoms follow the octet rule. Again, there are exemptions for that. But for oxygen, it's in the second row. It follows the octet rule. It should be surrounded with 8 electrons. Carbon would have 8 electrons coming from 4 bonds. So you have 1, 2, 4, 6, 8. Oxygen would have 8 electrons. So asa man na siya na kay 1 bond here. So you have 2. So kulangan kag 6. So there are 2, 4, 6, 8 or 2, 4, 6, 8 na kay tulo ka unshared pair of electrons. Tulo ka pair of electrons. Okay, so naanay duha ka dat. No? So when you look at on the formal charge of oxygen, ano sa inyong, diba, general chemistry, formal charge of oxygen, you have your valence electron of this atom, which is, for example, 6 minus number of bond, which is 1, 5, minus number of unshared electrons, which is 6. So 6 minus 5, that's 1 minus 6. 5 minus 6, that's -1. So oxygen here would have a charge of -1. Here, if you look at on the formal charge of oxygen, you will have group number of oxygen or valence number of oxygen. It's 6 minus number of bonds. It's 2 minus number of unshared electrons. Imaginary duha ka unshared electrons. So that's 4 minus 4 equals 0. So there is no formal charge. So you can see on the formal charge here for the structure is only on this oxygen. Okay, so wala na siya emphasize, because it is presumed that you have already mastered all this from your organic class. Okay? Kung wala nag-organic chemistry, wala na ba tuod na ako na-check whether you have finished your organic chemistry or not. So patay gitaan niya. Anyway, so back to our discussion here, and that's the reason why you have your negative charge on your oxygen atom. And of course, this is ionic. This is an ionic form. It should be bounded to another positive. Again, our source would be sodium. So sodium and your carboxylate, that we get our soap. So the properties of our soap, we get a mixture actually. Depend on our source of triglycerides. So if you have the same R, then you get all the same R here. But if you get the different R, remember your triglyceride, they can have the same R, or they could have different R here. So if you have different R, you would expect that you have different types of sodium carboxylate group here. So for example, nakay laureate, kani katong for example laureate your lauric acid, no? Okay, lauric meristic, so you have 12, 14, 16, 18. No, for example, Anna, or is it double bond, or is it saturated and unsaturated? Depende na siya din niya. Then depending on your R here, you get different types of soap molecules here. But overall, you get a mixture of soap, sodium soaps in your final product of your soap. Okay, so your soap is solid. This is a salt. We call this one as an organic salt. In fact, when you look at your mga paminta, mga magic sarap, mga bitsin, it's actually an organic salt you add, no? It's not the salt like sodium chloride or sodium bicarbonate. Those are inorganic salt. But something like this, where you have your sodium and an ion, and your organic, you have a salt here. Usually the carboxylate with a large group of your organic entity here. We call that one as an organic soap. So there are inorganic salt. There is also an organic salt like this one. And for example, you have sodium glutamate, one of the salt that you can find in your mga ingredients. So mga, for example, magic syrup, bitsin, we also have your organic salt. Again, these are examples of organic salt. One is you have your sodium soap, and the R would depend on your source of triglycerides. So the question now is,